So till now we have understand how the concept of controlling factor works, and we have also solved some one questions based on the same approach here. Let's solve few more questions to understand the grasp of the question. Okay, so in the continuation of the same one, if a person can choose between 1 to 9, okay, and again the condition is same, last one, the person who will choose the last one will lose, or last pick will lose. So this is the condition, and there are total of 15 or 36 coins are on the table, and two people like A and B are playing, and the question is A should pick how many how many to how many coins to ensure his win. So let's take the same approach. So first first thing is we need to see last pick lose. This is our condition, and it will be governed by the again controlling factor that is nothing but the sum of minimum and maximum. So the minimum is 1, maximum is 9. So 1 plus 9, it is nothing but 10. So the losing series will be nothing but 10k plus 1. So the person who is having 10k plus 1 will surely going to lose. So if there are total of 1536 coins, okay, so 10k plus 1, what is nearest to this one? This is 1530 is nearest. 1531 is the nearest. How many A will pick such that B will get this number? B will no, sorry, opposite actually. So total is 1536. The person who will have 1531, who will add the 1531 coin, will surely going to lose, so as our hero A is starting the match, so he always want 1536 to come to 1531. So how many he is going to choose? So the person, he will going to choose 5 coins. A will choose 5 coins. That's the answer of this question. It will not take more time to solve this type of question anymore. Let's take few more questions, and we will change little bit of approach. Till now, one thing, if we notice that one coin is minimum. Okay, so let's change the question and try to understand what if the conditions are different. So if conditions are different, let's take the question first. Question is, if again the same condition, last one picks lose. Okay, so now there are, suppose the possibility of a person to choose is at least 2 or 1, and the one more condition is being added, that is if last coin is left, if the last coin is left, then that coin has to be picked, has to be picked. And again the case is again alternatively between A and B. So this actually is saying that suppose if they are choosing, and suppose there are 3 coins last on the last, and it's A's condition, so A chose 1, so there are only 1 left, and it is written that minimum they have to choose 1. So one condition have been added, that if there is only 1 left, then the last person who has to pick the coin, he has to pick 1 coin, okay, and that person will going to lose. So this is the meaning of the question. So let's just understand how we are going to solve this question. So again, let's understand with the help of little bit of. So if one coin is there, so our A, if one coin is there, and yeah, again the same condition, that A will pick first, and how many he should pick to ensure his win. Considering one thing, that they both are smart, it's not like one person is dumb, they will do the mistake, no one is going to do mistake, both are smart, both are playing nicely. So if number of coins are 1, so if one coin is there, then according to this condition, A has to pick 1. So I can say that not favorable, it is not favorable for our A. So if one coin is there on the table, okay, because in the beginning when I started this lecture, I said that the approach this type of question by assuming the same condition with a smaller number, or in or take the question from the backside which is already been fixed. So question is fixed that the last person will going to lose. So we are saying that okay, there is only 1 coin on the table, then what will be the conditions? So we will try to find out what is the series it is making, or what are the similarities. So if 2 coins are there, so according to this, our A has to pick the 2 coins, and as our A will pick the 2 coins, he will going to lose. So this is also not favorable. This is not favorable for A. But let's come to the 3 coin. If 3 coin is there, what our hero A will do? A will choose 2 and leave 1 behind. So as 1 is there, so B has to pick. So I can say that this is favorable for A, because A is winning over here. Same thing, let's go for 4 coins are there. What could be possible? If 4 coins are there on the table, then I can make a graph also. If someone, okay, let me just make it little bit of. Which will be in okay. Suppose total coin, this is suppose, let me write total coin on table, total coin, then A picks, okay. After A is picking, okay, I will make a small one. This represents after A pick how many are left, okay. Then B picks, then A picks, then B picks. and this small red one will represent after that person picks how many are left for the next one. Okay, so suppose, as I said in the first time, if one coin is there, our A will pick one, okay, and he is going to lose. Same condition, if you see, if there are two coins, A has to pick two coins. A has to pick two coins and he is going to lose. But if there is three coins, okay, if there are total of three coins, what our A will do, our A will do one, and one, as one is left, one coin, so the B needs to pick one. As B picks one, our A is going to lose. So if four coins are there, our A will pick two. After that, what will happen? Two will be left, and there is no choice for B to do anything rather than to pick. Okay. So that way also, what will going to happen? A will going to win. Favorable for A. Similarly, let's see if this is the same case for 5. What will happen? Our hero, he always wants, see, now there is like you have to use your brain. If 5 coins are there, okay, and A have the liberty, A is smart enough and A has the liberty to choose between 2 to 7. Okay, A has the liberty to choose between 2 to 5, sorry, 2 to 5. So if A can choose between 2 to 5 and could bring here 2, do you think A will not do? Surely A will do. Like, A is not dumb, na? A is not dumb that he will choose 2, then B will choose 3, and then A will choose 1 and going to lose. A is not dumb. So what A will do, A will use his brain and he will say that, okay, if this is the case, let me increase the number. A will choose 3, and then with B is left 2. So 2, this is what B has to pick. Then again A somehow convince and win the game. So till what B can do this? So you will say that A can manipulate this game till here is 5 and here is 2. That is till 7. Till 7, what will happen? If here is 6, A will choose 4, 2 is left, then B is going to lose, A will going to win. Here also winning. If 7 is there, A will choose 5, and B will going to choose 2, then also lose. But the time when here comes 8, so 8 is kind of interesting. Okay, let me just extend these lines little bit. Yeah, what will happen with 8? Now A always has the option to choose between 2 to 5. He cannot choose 6. So A will try his best and say, okay, let's see that if A choose 5. So now how many are left? There are 3 left. Now the power is with B. B will do what B will do. B will choose 1 and then leave 1 for A. As A will pick A is going to lose. So A will lose, not favorable for A, because there is nothing A can do. Just think what A can do. Suppose, let's take one example. A choose 2. So how many are left? 6 are left. Okay, what will B will say? Okay, there are 6 left, but B also has the capability to choose between 2 to 5. So B will choose 4 and there are only 2 left. So at any cost we will see that A is going to lose in this case, because they both are smart. So 9 comes. With 9 also A will try, okay, what are my possibility between 2 to 5? Let's take 5. So how many are left with on the table? There are left only 4. If 4 are there, what B will say, okay, 4 are left, and then I have the power to manipulate the game. What B will do, B will choose either 2 or he can choose 3 also, doesn't matter much. If he choose 2, then there are 2 left. If he choose 3, there is 1 left. In either of the case, what will happen here, it will be 2 or 1. B will surely going to win, and our hero, that is A will surely going to lose. This is also not favorable for A. And then the tide will turn when there are 10. When there are 10, what will going to happen here? If we choose 5, so there are, how many are left? There are 5 left. If 5 left, let's see what will going to happen. B has also the possibility to choose between 2 to 5. Okay, so B won't choose 5. If B choose 5, then in this game only B is going to lose. So let's think that, okay, what B can do. B will choose, suppose 2. So if B choose 2, 3 is left. Now then when 3 is left, A has the power. A will choose 2, left is 1. Then our B will going to lose, and this is favorable for A. A will going to, or let's take different example now. If suppose here 5, now let's take that if 5 is there, so what B can do, B will say that, okay, I will choose 4. Or let's just take serial wise. B can choose, what B can choose, B can choose 3, B can choose 4, B can choose 5. If B chose 5, he will lose over here only. If B going to choose 3, how many are left? 2 is left. Okay, one thing to notice, I made a mistake over here in the understanding part. B is smart. B knows this possibility that this could happen, so B won't do this thing. Sorry, A won't do this thing in the beginning. See, A will say that I learned a lesson. I learned a lesson from my past. A will say, I learned a lesson from my past, and he said that 8 and 9 he used to lose. Then he will say that 1 and 2 he used to lose, so he hate these numbers. What he will say that, okay, if 10 is there, let me bring B to my place. Okay, either on 8 or 2. So A will say that, okay, if that is the case, let me choose 1. No, oh sorry, A can choose 1, so this is not possible. A will say that, okay, if this is the case, A will say that, let me bring you here. So what will happen? He will choose 2, and then in front of B there are 8 coins. In front of B there are 8 coins. Now what actually B can do? B know that he has a possibility to choose between 2 to 5. Let's take everything what B can do. 2, 3, 4, 5. Okay, if B choose 2, how many are left? 6 are left, because 8 minus 2 is 6, then 8 minus 3 is 5, 8 minus 4 is 4, 8 minus 5 is 3. So these are the possibility, like after B choose, this many will be left on the table. So if 6 is left, what A will say, okay, 6 is left, I will choose 2, and then how many are left? 1. Once the 1 is left, B is going to lose. Let me again write it over here. This is total. Okay, this is A, this one is B, this one will be A, and the last one, actually it should be outside. Let me put it outside so that no confusion is there. Last one is B. And those who are having trouble, let me tell you, this is what the remaining table after they choose. Okay, this is what remained. Once there are 10 tables, 10 coins, 2 is being chosen, so 8 are now left. Okay, just like if 8 coins are there, 2 is chosen by B, so 6 is left. So likewise, if you see, if 5 coins are left, what I will say, okay, if 5 coins is left, okay, let me do what I can choose. I will choose 3 and bring 2. Here also 6 coins are there on the table, A choose 4, he will bring on 2. 4 coins are left, A will say that okay, if this is the case, I will choose again 2, 2 is left. If 3 coins is there, A will say again okay, I will choose 2 and bring B to 1. And we already know that if B is on these places, B will going to A will win, or this is favorable condition for A will win. A will win. A will win. So what we could understand from this whole thing, that these two A don't like, and then what I said, these two, because if 11 is there, A can easily bring B on this point. We know that these are all the losing. Why losing? Because we know that there is nothing A can do than to lose. So this little bit difference further. Previously what used to happen on B, on this point A used to win because A can choose 1, but now that there is a limitation from the question that they have to choose 2 at least. So this is the change. This change is here with 1, with 2, with 8, with 9, and similarly when we go down the path we will find it will continue, but we can see that there is a series which it is following. So we can say that if we see the series, let's see losing number series. Let's try to find out what is the losing number series. So 1, okay, 1, 2, 8, 9. So 1, 2, 8, 9. So this is the losing number series, and 1, 2 already we know. This is what we can say that, can we say that this series looks to me like 7k plus 1 and 7k plus 2, because further down the path we can see, if we extrapolate the same thing, we can see that when there are 15 coins on the table, what will happen? A will try between 2 to 5. Suppose A choose anything 5, there are 10 left. So once there is 10 left, B is at this position. B will say that okay, you have chose 2, 10, I will bring you. B will choose 2 and bring A at 8. So is this the same? Can we say? But it cannot happen with 14. So if 14 is there, just suppose A chose 8, so here A can bring B at 9. Okay, so if you see that this is coming like 15 also, 15 and then 16 also, 15 also, it can be written as 7k plus 2, 16 also 16k plus 1, and here plus 2. So it can be written in this form. And as we from previous what we have already calculated and understood, there is controlling factor, that is nothing but sum of minimum and maximum. So minimum here was 2, maximum here is 5. So we can say that in this also series this is going to work 7k, but one difference is there. When the limitation is between 2 to 5, so we have to come till 2, 7k plus 1, 7k plus 2. This is the type of question. So if we extrapolate same kind of thing, then we can say that if we extrapolate the same kind of question, so if it is given that n is between 3 to 8, and again the last one lose, same condition, last one lose, or the last person who is choosing who is left with 2 or 1 coin has to pick that one. Both are smart. So we can say that if we have someone asks, okay, tell me fast what will be the losing series, so easily we can calculate. CF will be 8 plus 3, that is 11. So losing series will be nothing but 11k plus 1, 11k plus 2, 11k plus 3. So we don't need to always calculate this much or understand everything, but now that we have understood the concept, we can easily solve anytime. So on the same thing, on the same concept, let's take one more question. Suppose on the table 1263 coins are there. 1263 coins are there, and they can choose between 4 to 9. Last one picks will lose. Okay, will lose. And again the same condition, if less than 4, if at last less than 4 coins is left, then he has to pick. Okay, this is the condition. And then again alternatively, so how many the person should pick. So if you go by the again our basics or our approach, first thing is calculate the cf is minimum plus maximum. It is nothing but 4 plus 9, that is 13. Now find the losing series. It will be in the form of 13k, then till 4 is there na, 13k plus 1, 13k plus 2, 13k plus 3, 13k plus 4. So these 4 will be our losing series, and we know that on the table how many coins are there. On the table there are 1263 coins are there. 1263 coins are there. So tell me which one is nearest to this one. So nearest to this one will be 1263, 13 9 ja 117, 93. So 13 7 ja 91. So it's already in the form of 13k plus 91 6, I suppose. That is 97. No, wait, 97 na 97. Wait, let me calculate again. Guess I'm getting some 117, that is 93. Okay, and 91 13 7, so 2, yeah, plus 2. So A is already at the losing point. A is already at losing point, but still let's see if we can do anything. So if what we can say that 13k plus 4, if k is 97, then 13k plus 2 is 1263. So if k is 96, then our losing series will be 96 into 13 plus 1, 96 into 13 plus 2, 96 into 13 plus 3, 96 into 13 plus 4. So 96 into 13 6 8, carry 7, 78. Okay, 78, carry 7 117, 124, 1248, 1248, 1249, 1250, 1251, 1252, and we are at 2063. So nearest one is 2052, but still if he has to win, he has to, sorry, it will be A has to bring him here. So how many coins he has to pick to bring B to here? 11 coins, which is not possible, because maximum which he can pick right now is 9. So no matter what, A will going to A will surely lose this game. So in the same question, like A will going to lose, but if the question is little bit of different, repeat the same question with just change the coin 1272 coins. And the question is, find the sum of all possible values of x. So total coin now is 1272. CF is again the same question. 4 plus 9, that is 13. Then losing series will be 13k plus 1, 13k plus 2, 13k plus 3, 13k plus 4. So the nearest of it is nothing but 13, then again 117, 117, 9, 117, that is 10, 102, 13, 7, 9, 97. So 97 into 13 plus 11, I guess. Yeah. So this is already in the form of 97 into 13. So what we will do, if we will try to find the nearest one. So losing series, let's just write over here in 13k plus 1, 13k plus 2, 13k plus 3, 13k plus 4. So if k is 96, okay, or let's take 97 only. I think 97 is good enough. 97, if k is 97, so we have calculated here 96 now. So 13 into 97 plus 2 is 1263. So 13 into 97 is 1261. Okay, so it will be 1260. This is 1261, right? So it will be 1262, 1263, 1264, 1265. So how many 9 he can pick? 9. So can A bring 1272 to 1262? So he has to pick 10, which is not possible. Can he bring 1272 to 12? Can he bring 1262 to 1263? Yes, he can bring by choosing 9, correct? Can he do the same to 1264? I can say yes. If he choose 8, it's possible. Can he do the same? Can he do the same for 1265? I will say yes, he can do by choosing 7. So he can do by choosing 9, 8 and 7. And the question to us is asking, find the sum of all possible values of x. So sum of all possible value of x is equal to 10. Sorry, 10 is not possible now. 9 plus 8 plus 7, this is nothing but 24. So the answer of this question is 24. So let's recapitulate whatever we have done till now. So we are solving coin game related question. Okay, and till now we have dealt with, or let's highlight it nicely. And till now we have dealt with last pick lose. The person who will pick last will going to lose. So we have completed this one, and there are again many variation. Like, let's just recapitulate here what are the variation. If the person has to choose between suppose 1 to 5, so how we are going to approach this type of question? So this type of question will be first approached by CF. We will need to find CF is nothing but minimum plus maximum. So in this case it is 1 plus 5, so CF will be 6. Once we find the CF, what is the next step? The next step is to find the losing series. So in this case this is nothing but 6k plus 1. In next, what we learn that if there are, instead of 1 there are 2 coins, suppose here also takes 7. Okay, so here also our approach will be same. First thing is we need to calculate CF again. What is 2 plus 7? That is 9. And then again we need to find the losing series. Losing series is nothing but 9k plus 1 and 9k plus 2. These two will be our losing series. So if we go similarly to same path, if we go similarly to the same path for 3, if minimum of 3 they has to pick, our concept is not going to change. CF will again be 9 plus 3, that is 12, and the losing series will be 12k plus 1, 12k plus 2, 12k plus 3. Okay. So this is what we have done, but there is one more different type. Like here, let me just highlight it. First type was this one, coin game. Let me just adjust it little bit. When it can come in one page, why to bring it in cut paste? Yeah, so I can say coin game na. So till now this is what we have understood. Yeah, it looks good now. Coin game, the first part is last one pick lose. Or just go below the same. If we go 4, then 12k plus 1, 12k plus 2, 12k plus 3, last one will be 12k plus 4. So similarly it will go. Okay, but we haven't solved yet. What if the condition is second type of condition, that is last one pick win. The person who will pick last will going to win. We haven't solved this type of question. So this type of question is left for us to understand. So now that we understood how the whole concept is working, we have understand over here. If the list we have to choose is 2, we have solved here with whole concept nicely. Each step we have understand here with number of different cases also. What if happen if one, he has to choose between 1 to any number 7, 6, 5. So we have solved both of them. Just use the same concept. Okay, and let's try to understand what will going to happen if the last person is going to win. So let's just think once. So if 1 is there, let me just write over here again, total coin. If total coin 1 is there and the first person A is picking, then the A is going to win, because A can win anything. Okay, suppose let me give one limitation of the condition should be there, which will define the question. They can choose between 1 to 3. For the sake of understanding, let's not take bigger number. So if 1 is there, the list is 1 they can choose, so that person is going to win. Suppose there are 2 coins, what will happen? Again the same thing will happen. The person who is choosing first, he will choose 2, going to win. Same thing with 3, what will happen? The person who is choosing 1 will going to lose. But the scenario will change when there is 4. When there is 4, what will happen? No matter what the person wants, okay, no matter what the person wants, either he picks 1, 2 or 3, the last person will surely going to get coins on the table, either 3, 2, 1, and the last person will choose this, and he will going to lose. So again same concept, this is losing one. Let's just write losing. Okay, at 4, the first person who is choosing is surely going to lose. Let's take if 5 is there, what will going to happen? So if 5 is there, then the first person, what he will say that okay, 5 is there, I know, because he have already tested that okay, at 4 I have lost. So what first person will do? First person will choose 1, and how many will left? 4. He will bring the second person on the very same case where one time A was there or the first person was there. So now what will going to happen? If 4 coins are there, let's take different possibility that okay, 4 coins are there, what he will do? He either choose 3, let's take he choose 1, 2, 3. So if he choose 1, corresponding to that 2 coins are already chosen, so A will choose 1, 2, 1. So A is going to win. Green, na? Green. But here he is going to lose. Similarly, if you see on 6, what will going to happen? If 6 is there, then A can easily bring the first person on the same thing by choosing 2, right? And then I don't need to explain the same thing, because same thing whatever happened here, same thing happened over here also. Okay, it's like repetition. 2 again, then again 1, 2, 3, you already understand. If not, then do it on your paper and try to see. If 7 coins are there, he will pick 3, and how many will be left? Left already 4. So he will come on the same path, like again losing. But again, what happens if the coins on the table is 8? If 8 coins are there, can the first person bring the second person on 4? No, he cannot bring, no matter what he try. Suppose he choose 1, 2, 3, corresponding to this number. What the B will say that okay, you have already showed me what is the meaning of 4, so I will bring you to 4. If 8 coins are there, 1 already chosen, how many are left? There are only 7 left. Okay, I'm just writing over here how many are left. So 7 left. If you choose 2, 6 are left. If you choose 3, 5 are left. So B will say that okay, if 7 coin is left, why don't I choose 3, and I will bring you again at the 4th. The person who is at 4 is surely going to lose. If there are 6 coin, he will say that okay, I will choose 2 and I will bring you at 4. If there's 5 coin, he will say that I will going to choose 1 and bring you at 4. So again we will notice that 8 is also losing part. The same thing happened with what happened with 9. On 9, things will going to change again. How the things will going to change? A will say that okay, last time I know that at 8 I lost, so first person will choose 1 and bring the second person at 8. Once he is at 8, he is going to lose. So if we see this same continuum, we will see that the person losing series will something look like, let me write below, losing series will look like in the multiple of 4k. And again 4, if you use your brain, or if you use your previous knowledge, 4 is nothing but cf is what, 1 plus 3, that is minimum plus maximum 4. Okay, but the thing is here the losing series is, or wait, let me write it clearly over here. Cf is 1 plus 3 equal to 4, and losing series I'm writing over here, losing series is 4k. So in the old question, or in the last one lose, what used to happen, last pick lose, losing series used to be 4k plus 1, but here you can see that it is 4k. Okay, so as we solved in the last one series, that once there is 1, so we choose 2 and try to understand how the question will go. So similarly we will do in this one also. So suppose in this one, this is a, okay, wait, let me just make some space for this condition to accommodate. Yeah, this is the a part. Similarly a part of last one lose, a part we choose 1, so the b part you already have guessed, so b part will be 2, and let's take 4, let's not complicate by taking the big number. And then again same conditions, which let me write a little bit, a and b alternate. Okay, and if last, again if last coin is left, if last coin is left on table, if last coin is left on table, whosever chance it is, it needs to be picked. Okay, if one coin is there, then he has to pick. So again let's use our brain. If one coin is there, first person will going to win. Okay, oh sorry, first person will going to lose. One coin is there, he can, no, first coin, sorry, my bad, first coin is there, then yeah, according to this rule, first coin is going to win. If two coin is there, that person will pick 2 coin and going to win. Correct, let's go. 3 coins are there, he can choose between 2 to 4, so still he can choose 3. Okay, some people might have the doubt why 1 coin is he is going to win, because the condition is this, but here also it is written na, if last coin is left, last coin, 1 coin is left on the table, the whosever chance it is, it needs to be picked. So only 1 coin is there and it is A's chance, so A has to pick because he got 1 exception. Okay, but when 3 coin is there, he can choose 3 coins. Okay, so this is how it goes actually. If there are 4 coins, what will going to happen, he is going to choose 4 and he is going to win. But again the things will going to take turn when there are 5 coins. When there are 5 coins, no matter what, see, now you will understand what is the meaning of this line. So someone might say that okay, first person will choose 1 and then bring 4 for the another, but the thing is 1 he cannot choose no matter what. 1 is only when the last coin is, this is not the last coin, there are more coins are there. If only 1 coin is left, then it can be done. So no matter what he is going to choose, this person, suppose he chose 1, then there are 4 left, that person will choose. If he chose 2, there are 3 left, he will choose 3. If there are 3 he chose, then that person will be 2 left. If he chose 4 also, there will be 1 left, he is going to lose. So I can say that when 5 coin is there, then he is certain that he is going to lose. Let's come to the next condition. When 6 coins are there, if the first person choose 1, oh sorry, again let me correct myself over here, I did one mistake. So he cannot choose 1 coin, no, there's no possibility. He can choose between 2 to 4, that is what I have written over here. He can choose between 2 to 4 and he chose between 2 to 4 and still he lost. Okay, he is still lost. He cannot win the game. So suppose there are 6 coins and he chose 2, he can choose 3, he can choose 4. If he choose 2, if first person choose 2, how many are left on the table? 4. That person will choose 4. If 3 coins he choose, the second person will choose 3. 4 coin he will choose, 2 are left, so he will choose 2 and ensure his win. The second person won. So this is also not a favorable condition. So we can say that this is losing series. This is also a losing series. If there are 7 coins, what will happen? He will say okay. Now he will say that okay, I know that at 5 I lost. So he will say that okay, I will choose in my first chance 5. If 5 he choose, how many are left? If he chose 2, if he chose 2, 5 are left, and I know that no matter what the person will do, if there are 5 coins, he is going to lose. So again, he will start winning the game. Similarly, if you see at 8 also, he will win because he can bring either at 6 or 5, anything he can do. Okay, let me just write it here in the blue color. 8 he is going to win. If 9 coin are there, again he is going to win. So 10 coin there. If 10 coins are there, let's see, if 10 coins are there, he can choose 4 and bring at 6, so he is going to win. But once again here if here 11 coins, again we will see the problem coming. If 11 coins are there, can he bring either at 6 or 5? Can he bring, if he choose maximum of 4, he can bring at 7, he cannot bring at 6 or 5. So again we will see that if 11 is there, he is surely going to win because he cannot bring the other person or either 6 or 5. Okay, same thing will go for 12. If 12 are there, no matter what he choose, he cannot bring, because 12, the least he can take first in the first chance is 2. If he could choose 1, then he can defeat by putting the other person on 11, but he cannot choose 2. So this is what the changes in the question is. But again, when the condition is 13 coin, he can bring at 11 by choosing 2. So these two are again losing series. So if you notice nicely, then our losing series, let's just write first losing series. How does it look? Losing series is nothing but 5, 6, 11, 12. See, 5, 6, 11 and 12. So can I just say once, by looking at this, that it can be written as in the form of 6k and 6k minus 1. 6k, here k value is 1, so 6 into 1 minus 1, this is 5, this is 6k, so 6k minus 1. So if k is 2, so 6 into 12 minus 1 is 11. Here is 6k into 12. So again, if you notice nicely, then we will find that controlling factor is again controlling the situation over here. Controlling factor, that is nothing but minimum plus maximum, and then again it will be 2 plus 4, that is nothing but 6. So similarly, if you understand, 4 plus 2 6 or 2 plus 4 6. Okay, so similarly, can we say that if the same kind of conditions are there, let's take the C condition, ABC, if the condition is to pick 3 to 8, then again our basic application, how to solve this type of question. Find CF is what? Minimum plus maximum, minimum plus maximum. 3 plus 8, that is nothing but 11. So our losing series will be 11k minus 1, 11k minus 2. Easy. So this is how this question will, or this approach will work. Or let's just take one example and try to visualize this question. If let's just write over here, if the chance is either 4 to 10, okay, 4 to 10, then let me just write both the cases, what will going to happen in both the cases. Okay, suppose that this one is last pick lose, last pick lose, and this is last pick win. Let me just highlight the difference, lose and win. If this is last pick lose and last pick win, one thing that is sure for both of them is CF. One thing that is sure in both the cases is CF. CF is not going to change. CF is 4 plus 10, that is 14. So the losing series, let me just write first losing series, then I will write all the losing series. And losing series in this case, losing series in this case will be again how it started. So 14k, we remember 14k plus 1, 14k plus 2, 14k plus 3, 14k plus 4. This is for losing series. Okay, this is for losing series of the person who picks the last pick. Okay, let me just highlight this last part, last or the last here, the last one pick lose or last one pick this one. So similarly for losing series, the last one pick will win is nothing but again it will start from 16k, that is the difference. Okay, here it started with 16k plus 1, but here it will start from 16k only, sorry 14k, 14k minus 1, 14k minus 2, 14k minus 3. Okay, so if we understand this question, let's try to solve one question. Okay, let's try to solve a question on this winning series. A and B are playing game. A and B are playing a game. Okay, alternatively, and the condition over here is last pick win. Remember, last pick win, this is the difference now, and the condition is he has to pick between 3 to 11. He can pick any number. And sorry, so if there are 15 19 coins on the table, and it is chance of A and A picks X coin and ensures his win, then the question is find sum of all possible values of X. So you can solve by pausing the video, but let's try to solve with the same concept which we have done just now. So if there are total coin is how many, let me just write by my own method. There are 15 19 coins. The value of the coins, like how they can be picked, is this one. So first of all, let's just find CF. First approach, that is nothing but CF. 3 plus 11 is how many? 14. Let's find the losing series. To find the losing series, we need to know if it's last one lose or last one pick. So this is last one pick, last pick win, last pick win. So we know that it will look like 14k minus 1, 14k minus 2. Okay, so nearest to this one, what I will see that 1 0 and 119, anything 14, 112, no, So 1519 is in the form of 14k plus 7, or to be precise, this is nothing but 14 into 108 plus 7. Okay, yeah, there's one more way now. I did let me just now tell you. If someone asks me, okay, tell me 1519, so do one thing. 1400, we know that this is 100 into 4. How many are left? So it's easy to do. 119. So the next one is nearest to it, 14 into 8. Okay, 14 into 8 is nothing but 112. 112. So 1512 is 108 into 14. Okay, that is what I wanted to do. So 1512. So let's find out the losing series. Okay, losing series. Losing series. Losing series, what it looks like: 14k, 14k minus 1, 14k minus 2, right? Or 3, no, 2, till 2. Yeah, 14k, and we know that 108 is 1512 and 1512, and on the table again, let me write, otherwise I will forget. 1519 coins are there. 1519 coins are there, and if k is 108, so how much this value will be? This value is 1512. This will be 1511. This will be 1510. So can this value becomes this? How it will becoming? Let me just give for every. It can become this if first person choose 7, if first person choose 8, if first person choose 9. Okay, these are the only possibility, but let's check. Yeah, can we choose? Yeah, we can choose between 3 to 11. So all these three are possible. So sum, and the question, I guess, sum again asking us sum of all the possible value. So sum of all the possible value, sum of all the possible value is nothing but 7 plus 8 plus 9. 7 plus 8 plus 9, 24. That is the answer. So we have done till here. In the next class, let's solve to some sets. Okay, together, let's solve some sets.